Hi, I'm Papia, and in this problem, we will write the equations of tangent lines to the graph of a given equation at some given points. So in this particular problem, this is the equation that's given to us, x squared plus y squared equals 100. As you can clearly see that this represents a circle. And the points are 8, 6 and negative 6, 8. So we have to write the equations of the tangent lines to the graph of the circle at these 2 points. All right, so let's think about it. What do we need to write equation of a line? Well, we need slope and we need a point on the line. Now notice that these lines are going to pass through these points. We have to write equations of 2 lines. And so the points are already there. All we need to find is the slope of this line, right? Okay, now let's think one more time. What kind of line are we looking into? These are tangent lines. So what do we know about slope of a tangent line? How do we get slope of a tangent line? Well, it's just derivative, right? So if we just find dy dx, that'll give us slope of tangent line, and we plug in the points and we'll get those particular slopes. So let's work this problem in few steps. So the first step will be to compute slope. And you know that we have to compute dy dx. Okay, so we have our equations, we have to compute dy dx. So let's start there. So the equation is x squared plus y squared equals 100. Now notice further that this is an implicit equation. It's not an explicit form. So in order to compute dy dx, we need to do implicit differentiation. So let's try that. What do we need to do is we do d dx both sides. So we apply d dx both sides. So let's see. We'll do d dx on the left and on the right. Okay, this is implicit, remember. So let's try to take the derivative of each term at a time. So we have d dx of x squared plus d dx of y squared. Now the right hand side, let's compute this derivative right away. What is the derivative of 100? It's a constant, and we know that the derivative of a constant is 0 with respect to any variable. So that is easy. Now the left hand side, right? Now notice implicit differentiation. We are taking derivative with respect to x, and we have the variable x here. So it's the same variable, right? We have x and x. So the derivative is just simple power rule. So it will be just 2x. But the second one, we are taking derivative with respect to x, but look, this is a different variable. It's y. So this is like a function, square. So we have to do chain rule here. So what is the chain rule? First, it is y squared. So we have to use power rule, which is just 2 times y. But then you have to go one step further, is chain rule, right? So you have to have d dx of y or dy dx. So that extra piece will be there. And the whole thing is equal to 0. And now we have an equation. We have dy dx there. You just solve for dy dx, and that'll give us our slope. So let's solve. So you keep the term that has dy dx on the left-hand side and take the other term to the right as negative 2x, and then divide by 2y both sides. So dy dx is equal to negative 2x divided by 2y. Cancel the 2. This is negative x over y. So this gives the derivative of this function, this equation, and this is also the slope of tangent line to the graph of this equation. But we have to figure out particular slopes at these points. So let's try that. So that's step 2. So what is the slope at the first point, 8, 6? Let's call it m1 so that we can differentiate between the 2 equations later. So what we do is we take the derivative and then plug in the x and the y values. Okay, so it will be negative of x divided by y. X is 8, y is 6. And simplify, so 8 over 6, that will be 4/3. And let's compute the next slope. So what is the slope at negative 6, 8? Let's call it m2. Again, it's negative of x over y, so negative of x is negative 6, y is 8. So this becomes a positive quantity, 6 over 8, so it'll be 3/4. All right, so we have both slopes. Now we have to write down the equations of the tangent lines. So that's step 3. Okay, so the line that passes through the first point, let's call it equation 1. So the slope is m1 and the point is right here, 8, 6. And we know how to write equation of a line given a slope and a point, right? It's the point-slope form. So what is the point-slope form? It's y minus the y value that's given to you, y1, that's 6. That will be equal to slope m1, which is negative 4/3, times x minus x1, which is the x value of the point. So 8. If you want, you can simplify a little bit. So let's write it in explicit form. So y is equal to, let's see, we have negative 4x over 3, negative 4/3 times negative 8, so that'll be a positive 4 times 8, 32 over 3, and then you bring the 6 to the right-hand side, plus 6. And you can go one step further and add these two together. So this will be 32 plus 6 times 3, that's 18. So it'll be 50 over 3. All right. So to complete the problem, we have to write one more equation. So the second equation, this is the equation of the tangent line that passes through this point, negative 6, 8, and slope is m2. Okay, so we just follow the same method, so the point-slope form. All right, so the equation is y minus y1, and in this case it's 8, will be equal to, slope is 3/4, times x minus, look, the x1 is negative 6, so be careful because it will become a positive quantity there. All right, and you can simplify again. So y minus 8 is equal to 3x divided by 4, and then this is plus 6 times 3/4. So that'll be 18/4. And you can bring the 8 to the right-hand side and add the two constants together. If you want, you can simplify this quantity a little bit more. This becomes 9 over 2. So let's see. Y will be equal to 3x over 4 plus 9/2 plus 8. Okay, so what is 9/2 plus 8? So that'll be 9 plus 8 times 2, 16 over 2, and 16 plus 9, that's 25. So finally, the equation is y is equal to 3x over 4 plus 25 over 2. All right, so we have the equations of two different tangent lines passing through these 2 points on the graph of this circle. Now, finally, we have to graph the circle and the two tangent lines in the same window in a graphing utility. So pick any graphing utility that you have, and let's plot these. So you already know how to plot lines. These are just lines. So you can just plug in y equals negative 4x over 3 plus 50 over 3 for y1, and then in y2 you can plug in the next equation. So 3x divided by 4 plus 25 over 2. And you can just graph it, right? But those would be just two lines. Now we have to see if they're tangent lines to the circle or not. So you have to graph circle. Now notice you can rewrite this equation and make it an explicit form, so solve for y, but then you have to remember that there will be a positive and a negative portion. So you have to write two different equations. So you can do it that way, or you can use a draw circle. So if you go second and draw, and then you go down and find the circle draw, and then go there, and you put in that bracket, you write down the center of the circle, and you see the center is 0, 0. So you write down 0, 0. And then if you notice that 100, that is giving you what is the radius of the circle. So 100 is 10 square. That means the radius is 10. So you put 10 there, and there you go. That's your circle. And then you graph it, and you will see that you have the circle, center 0, 0, radius 10, and then these two lines are tangent lines to the graph. So this completes the problem. Thank you.